Hi, this is Brian Knapp from HowRadiologyWorks.com. What we're going to talk about today is in the context of radiation biology, the effects of the radiation specifically on somatic cells and specifically the effects that are not related to cancer induction or carcinogenesis. So if you're wondering what somatic cells are, or if you're wondering the relationship between lymphocytes and nerve tissue in terms of their effects to radiation damage, then this is a good video to check out. And if you're interested in this type of content, which is about bite-sized content in radiology, click on subscribe below and then click on the little bell icon to get notified when we release new content. First off, what's a somatic cell? So germline cells are cells that are going to be passed on. So sperm and ova will be passed on to the next generation. Somatic cells are cells which are in your body but which are non-germline cells. So today we're going to talk about somatic cells and specifically the things that are unique to somatic cells with respect to radiation. So we have another video where we go through just this chart because at a high level this is a classical description of the way in which radiation damages the body. And you can think about especially X-ray radiation. X-ray radiation comes in, X-rays interact via Compton and photoelectric effect. And Compton and photoelectric effect both result in energetic electrons that are going to deposit their energy locally. They deposit their energy locally, and then after they've deposited their energy locally, those energetic electrons can either cause free radicals to occur locally. Those free radicals can damage the DNA. That's called indirect action. Or if the electrons damage the DNA directly, that's called direct action. And then that can lead to either cell death, in which case you could have radiation sickness or fetal or late effects, or DNA mutation, which can lead to cancer or inherited effects in the case that DNA mutation is occurring in germline cells. Since we said we're not going to talk about germline cells in this video, we're not going to talk about cancer induction in this video, we're primarily interested in this path over here where cell death is the primary reason for the radiation damage. And this radiation damage, if we think about it, there can be multiple cases wherein the radiation can interact. That radiation in the DNA can be repaired. If it's repaired properly, because as we talked about in other videos, we do have redundancy within our DNA. So if it's repaired properly, there can be cell division, and we can go on as if nothing went wrong here. However, if it's not repaired, there's multiple cases in which damage can occur. And if the damage is very significant, that could lead to direct cell death. So that's the cell itself dying via, for instance, apoptosis, which is an induced cell death. Or we can have cell death in the second generation. And in the second generation, this means the cell itself didn't die, but it still had enough damage that it couldn't reproduce properly. So those daughter cells then die. Finally, it's possible to have damage which is not repaired, but which is not known. It's not significant enough to be known, such as the programmed cell death does not occur. And in this case, there can be mutation, which is then propagated down the line and can lead to inherited effects or cancer induction, carcinogenesis. So today we're primarily talking about these effects here, wherein cell death is primarily leading to these effects on the somatic cells. We also want to mention acute versus chronic. These are just general terms, but they're part of the ART summary spreadsheet. So we want to be familiar with them. We want to know that acute is just those relatively short periods of time wherein higher doses are delivered in a short period of time. Typically the effects are relatively immediate, so seen just within a few days. And then chronic are long-term effects and can occur with a lower radiation dose, and also if there's a radiation dose that's given over time, that can also be more likely to lead to long-term effects. So cell death, again, is primarily caused by higher radiation doses. And the short-term effects, for instance, acute radiation sickness, we have another video on acute radiation sickness. And then long-term effects include, for instance, cancer, inherited effects, and cataracts, which we have separate videos on each of those as well. And then the one big takeaway for today's lecture is the organ and tissue response. So the frequency of the reproduction, so we talked about if there is X-rays, if there are X-rays that are incident on those cells, and especially if that happens while they're trying to reproduce, because of the frequency of reproduction and because that cells are more radiosensitive while they're reproducing, that means that those cells that reproduce more frequently have a higher radiosensitivity. So like we talked about in the very first slide, lymphocytes or blood cells, those cells within your white blood cells, those are constantly being replaced within your body. So those will be very radiosensitive, and compared with muscle tissue and even below muscle tissue would be nerve cell tissue, wherein those are getting replaced very infrequently in your body. So this is kind of the order in which we note that there's a correlation between the radiosensitivity and the frequency of the reproduction of those types of cells. So at a high level, what we reviewed today were some special concepts related to radiation biology, specifically for somatic non-germline cells for non-cancer induction. And the big takeaway is that the frequency at which the cells are reproducing is related directly to the radiosensitivity, because during that reproduction, the cells are more radiosensitive. Again, this has been Brian Nett with HowRadiologyWorks.com. Thanks again for tuning in to How Radiology Works. Leave a comment below and let me know what your favorite part about radiation biology is. Is it the alphabet soup, RBE, LET, OER, or do you like deterministic versus stochastic, or what specifically is your most the part you find most interesting about radiation biology? So yeah, write that below, and then also go on over to How Radiology Works /radbio to get your cheat sheet, and that has a condensed form of all this material. So if you want a study guide for just a one resource in one place, have a PDF, or just to have in general, go on over to howradiologyworks.com /radbio. Thanks again.